Olá, bom dia a todos. Boa tarde, boa noite. Thank you for tuning in, and thank you for our host for inviting me to speak here today. I hope it's going to be useful or at least entertaining. So I have a few stories to tell. Let me get my sharing going. So you're just not looking at my mug. Okay. So we're gonna test war stories today. So my name is Andreia Gaita. I am from Portugal. I am currently in Copenhagen, Denmark, where I live. I'm a technical lead at GitHub on the editor tools team, and we do GitHub editor integrations like GitHub for Visual Studio and GitHub for Unity. I'm not sure if you've worked on these, but I actually have screenshots later, so you can see. I previously worked at Unity on the runtime and scripting engine and the Unity game engine. And before that, I worked at Xamarin and Novell, where I worked on the Mono project. And before that, I did consulting. I had my own company. I did web development. And I spent a lot of time in IT departments at financial institutions building things. So I'm not a QA person by trade. I've never had a dedicated QA job. I am, however, a cross-platform developer, and I spend a lot of time porting and re-implementing and replacing existing software, and also designing and prototyping tools. And testing is absolutely integral part of all of this work. So testing is a thing that a lot of developers go, oh, I have to write tests. It's boring. This usually comes up hand in hand with the discussion of what types of tests to write. When do I write a unit test or do I write an integration test thrown around? And sometimes like people just write tests so that other people will shut up about the test that they have to write. So I'm not QA because I forgot to flip the slide. So this is the screenshot of this is GitHub for Unity, actually. So this is the stuff that I do, and we're gonna discuss my first war story, which is the mocking incident. So I'm starting with this story because this is the only story that I have that highlights negative sides of an extreme test-driven development mentality. This isn't trying to put TDD down, and what I hope to highlight here is that every practice is a tool that you can either use to your advantage or use to shoot yourself in the foot. This whole incident is not what TDD is, but what someone thought TDD was. So once upon a time, there was this new project ramping up for this massive application, so that the parts of the application could be updated independently of other parts because the application was massive. This would help individual teams ship their features faster because they would no longer be dependent of a single ship point that everybody had to synchronize on, like every 3 months or every 6 months. And users could get smaller updates just for the parts that they were actually using instead of having to wait months for the fixes that they wanted to come along with all of the other fixes they didn't care about because they didn't use those parts of the application. So now the project was assigned to a person that had been trying to introduce testing first attitude at the company for a long time with very limited success. This was the kind of company where it's like, what are tests? There was just a general lack of standardized testing infrastructure and practices. It really didn't get a big buy-in from senior people at the company. And most developers had never had done any testing in their careers whatsoever. So it was a really hard sell internally. That's since changed, but that was like the picture at the time. So it was like there's meetings going on about like we should introduce testing and we should have like a proper CI set up, so continuous integration, so we always test and everybody should push tests with their code. And this was like, but that's hard, and like it's hard. So it never really caught on. So this person was naturally frustrated because it was really hard to change like the culture internally. And when this project came along, they were completely determined to show how test-driven development could be used to create better software and really like push it out of the gate as a success. And it's just like showing off how you could do things in a test-driven way. So now like the team was small, and we were busy with a lot of projects. And like any other teams in the company, code reviews only really happened when branches were getting ready to be merged to master. So everybody had their hands full on their own stuff, and everybody was doing their own thing. Some months pass, and the project is coming along steadily. Code is getting checked in. Internal CI is set up. It's running all the tests. Things are just moving along nicely. And then the unexpected happens, and the person and the company part ways. So now we have this really crucial project on our hands that business division was keen on having because they could ship faster and etc. And we kind of have to figure out who's going to pick it up and go with it. So I picked it up. So this was right at the time where we had our team summit. Which is where we went somewhere in the middle of nowhere and figured out what projects we would be doing for the upcoming year, prototype things for a whole week. And so this is like, okay, this was right before we left for that week. So I dove into the code base of the project to get familiar with it so I could just continue the work and we could discuss everything, like how this would go on during the summit. So diving into unfamiliar code bases is kind of one of my specialties. I do that a lot. And this particular code base was a solution with something like 10 projects. It was fully tested from a senior developer, an agile coach who absolutely knew what he was doing. And I figured this would be pretty solid stuff that I could continue working on. And then I basically had to throw most of it away and start from scratch. So what happened? You see, so this was TDD driven to the most extreme levels possible. There were countless lines of code. I had no idea how many, but there were like 10 projects. So there's a lot of lines of code written over a few months, hundreds of tests, tons of interfaces in the dozens. But there was no actual implementation. There's no actual functionality. Everything was mocked to describe exactly how each individual component would have data in, data out, but no component was actually implemented. It was just big, huge facade with nothing behind it. Still to this day, I'm amazed at how you could write so much code that does absolutely nothing. It was really impressive. It was like a coded description of all the components of it's like a design spec, but written in tests. So, problem number one. There was a lot of problems with this, but problem number one was organic system design. So, because the whole system grew out of individual mocked tests, every component was highly modular and split up, completely isolated from each other. It was completely impossible to control the lifetime of any component or even figure out how to bootstrap the system. Everything just magically came into being via dependency injection. Because when you have a highly isolated set of components, loosely coupling them usually involves some sort of inversion of control and dependency injection. There are great ways to make use of these mechanisms, but there's such a thing as too much decoupling. And when a system is not designed and just grows organically from tests, exaggerated decoupling is usually a side effect. So letting the design of the system just spring up from the needs of whatever individual test you were writing at the moment is not really designing the system. It's just letting it emerge from chaos, basically. It creates a tangle of components that quickly become unmaintainable with interdependencies not being thought out and specced out. Anyone trying to change anything in the system risk massive cascade ripples of effects and breakage. Systems should be designed, they just don't spontaneously occur. So this was completely unmaintainable. Like, you pulled one string and everything just broke in weird ways. Keep in mind, because there was no actual functionality, it was just tests, which comes to problem number 2, implementation walking. So every test focused on testing a very specific piece of the system, mocking everything else around it, which is fine if the functionality that you're testing is actually there. But if every line of the test is exercising a mock facade, then that's not a test. It's just a statement of intention. It's not a test. A test tests things. It has to test something. If it doesn't test anything, it's not a test. A pass on a test means that the implementation being tested actually ran according to the specifications of the test. And the key word here is implementation. If you have a green test when the test is running against a facade, a fake mocked implementation, instead of the actual implementation that you're testing, the test is lying to you. It can't ever be read because the test itself is providing the implementation via the mock, so it can never fail. So this isn't a test. This can be many things, but not a test. If you're writing a test for functionality that does not exist, it should totally fail. It should be read. And that's a good thing, right? That means the test is not prescribing what the implementation should look like. It is only dealing with what the implementation is doing, like the inputs and outputs. And if the implementation is not actually there, well, the test then is read. It should be read. All of these tests should be read. Because otherwise, how can you tell whether something is green because there's no implementation and something is green because the implementation works as intended? It's not real. So when implementing a new feature, having red tests is great. Red tests are not a bad thing. They're a great thing. There are some things you want the feature to do up front, so you can write those tests to document the assumptions that you expect of the system. And when you start implementing and your assumptions are going to change because the real world sucks and all of those nice things that never go according to plan, and you adjust the tests to reflect the changes of assumptions as your understanding of what you have to do grows, and you had more tests for all those other conditions that you suddenly realize you need as you're implementing the feature. And you have these red tests constantly while others are green as you implement things. And when all of the tests are finally green, the green check actually means something. I'm not sure whether I don't know what the thinking was that it was weird. So the third problem, there's a lot of other problems with this approach, but the third problem was assumptions. So assumptions are the mother of all screw ups. Let's call it screw ups. Do not use other words. Like, assumptions are the worst thing. They always bite you. Because the entirety of this system was a reflection of the initial assumption of what it should do or it would do ideally, it didn't actually reflect what the system had to do and what the system had to deal with. All of the unknown cases, all of the edge cases, or all of the things that come up when you actually start to implement and run into actual problems that are beyond just the code that you're writing, especially if this involves networking code and other things that it did involve. So it was all built on this huge number of assumptions of how things would potentially work. And like, with enough experience developing software, you kind of build up a mental picture of a lot of the problems that you're going to have to deal with along the way when you're implementing something. But that's by no means a complete picture, regardless of how much experience you have. If you design a system on paper based purely on your assumptions of how the world works and what you imagine the needs and problems of the system and the users might be, and then ship that, well, that's going to last about 5 seconds in the real world. And then it's going to not work. And worse, investing that much time in building a complex system facade without actually starting on the implementation means that if some unforeseen thing is discovered later during implementation, it has the potential effect to destroy the whole house of cards by forcing a re-architecture of something. It would just pull on a string and everything comes crashing down. And this is a side effect of a problem that I call the 99% bug compatibility problem. Well, and I'll talk more about that. But essentially, if you don't check your assumptions by actually checking the assumptions, you're going to have problems. So I don't know what slide is next. Yes. Moral of the story on this one. You can shoot yourself in the foot with anything. Every practice is a tool that you can use to shoot yourself in the foot with. Like, no practice is perfect. They're all tools that should be used with measure and caution and like appropriate to what you are doing. And if you overuse them and you abuse them, or you use them in the wrong context, you're going to shoot yourself in the foot with. TDD is not system design. There's this writing tests up front of the feature and designing what things should be and how they should look and how should they be used, whether it's an API or UI or UX. There are two different things that are complementary, but one does not replace the other. And you cannot grow good complex systems just by writing tests and hoping logic emerges out of them, no matter how nice that looks or feels. It tests things. If the test doesn't actually call something that you're testing, it's not a test. It's documentation. It's a design spec. It's thoughts on paper. It's not an actual test. A test tests things. It's important for the test to actually, the green check, to mean something. So that was my first, I think, major encounter with the goods and bads of testing. I took some of that code away and rebuilt the system. And I obviously wrote tests for all of this stuff. It kind of burned me a bit, though. It was just like so completely surreal. I wish I had the code because it was very surreal and impressive that someone could just write so much stuff that did nothing. But it's a lesson that I keep with me whenever I'm over designing systems. It's important to check your assumptions and like actually make things work to see if they work instead of over designing. So what are tests? I'm not, again, QA, don't have formal training on this stuff. So there's unit tests and integration tests. There's formal definitions for what these mean. I don't really find the definitions very useful personally, because they're technical definitions that highlight how much of the system the test touches, where like unit tests are very isolated and test a small portion outside of the system, just a little bit. And the integration tests system, like the system as a whole, tests multiple components and how they integrate with each other, but they don't actually describe the role of the test. Like, what is the role of this test? So I prefer to think of tests in different ways. There's assumption tests where the tests are written up front, usually when creating any feature. It's like, these are the assumptions that I have on how the system is supposed to operate and all of the variations that I can think of up front. Like, okay, I'm going to write a feature of something. And it's just like, I'm going to write all these tests, and these tests are going to be read. I'm assuming like these are the method calls, and these are the ways that the two components are going to interact. I'm just going to put stuff together and Just let them throw and be read. There's no implementation there. But these are just documenting how I think this thing should function. If one of these tests, and then I make test screen and I build a feature and I make these test screen. And then if the tests, and then I continue building things and adding more tests. And if one of these tests goes red at some point, it's a sign they either broke something or that the assumptions have changed. And the test needs to be changed to reflect those assumptions. So these tests are not written in stone. They reflect the current assumptions of the system, and those assumptions change. And they are there to make clear what the assumptions are. So if it happens if I change something, a test goes red, I decide that the assumptions have changed, and I rewrite the test for the new assumption. The test is documenting what I assume that the system does. It also happens that I change something and tests go red. I go and look at the tests and I remember why I did the thing that I did at the time. And then I undo the change because the test is telling me, this is the assumption that you have on the system. Sometimes it happens that I change something and tests go red that require me to do other fix-ups in other places in order for the whole thing to be consistent. And then that causes a ripple effects down the code base. And there's all the other tests go red. And now I have to change this and this and this and this and this. And sometimes I keep at it. Sometimes I realize the impacts and back off from the change. Tests need to evolve with the code base. They need to grow as the code base grows and change as the code base changes because systems change. And if they become useless, I throw them away because they're not useful anymore. These can be unit tests. These can be integration tests. There are tests that document upfront what I expect the things to work so that I can later know how I expect the things to work when I do changes to the code. So now there's regression tests. So these are tests introduced after something is broken to ensure it doesn't break again. They can be unit tests, but most often they're integration tests just because that's how things break. It's not an individual module that breaks. It's the interaction between things that break. So when a test breaks, when a test goes red, this is a problem because if there's a test for something, it's because there was a bug that was identified. We've already classified it as a breakage. It's not a change of assumption. It's a bug. It's not a feature. It's not anything. It's a bug. And we fixed it and we wrote a test to ensure that the bug doesn't happen again. So if that thing goes red, that's a bad sign. You should not be ignoring it. It should not be rewriting it to go oh yeah, that should be a sign. It's a canary in a coal mine sign that something is going wrong. And after the system has been shipped, then things are stabilized. Every fix should come with a regression test if it's a fix for a bug to make sure that it doesn't happen again. Then there's documentation tests. And sometimes all these tests overlap to each other depending on regression tests usually have a bug number assigned to them, or you can find them easily because they're in the commit that fixed the bug. But assumption tests, sometimes come early, sometimes come later. Documentation tests are tests that are useful, obviously, but they are tests that are very useful to document how people should use the software. So when I go into an unfamiliar code base, the first thing I do is look at the build system to figure out how to build it. And then I immediately go and look at the tests before even looking at anything else in the code. I do this because tests are isolated pieces of code that describe how to initialize and run and use the software, usually in a very precise way and in a very efficient way because they're trying to do this with a minimal amount of code. Because that's literally what I have to do to test things. So having tests that demonstrate how to do particular things with the software is way better than 10 pages of text explaining how an API works. If you hate writing API usage documentation, I highly recommend just writing tests because those are really good documentation. And the thing with documentation tests is they work best if they actually go through most of the steps and avoid mocking. So they're most likely going to be integration tests. They don't do much, but they just demonstrate how things should work without a lot of mocking, because mocking distorts how you look at, like, how you would actually do this in real life code, because mocking is mocking things, right? And there's always more steps to actually doing something than what looks like when you mock things. So these are more likely to be integration tests, and depending on what type of code base, these fit more or less. If it's a tool that runs on the command line, these are amazing, because if there's tests that actually run the tool, then you can see how you can actually run the tool. So documentation tests are pretty darn useful. And then there's black box tests, or reverse engineering tests, or mapping tests, which I will explain with another story, because we're talking about stories. We're talking about 99% bug compatibility, which is a mantra that I have in most of my projects. So I've spent a large portion of my career porting software, making things run in systems they were never designed to run on, and replacing pieces of functionality without breaking the whole system that relies on it, just swapping things in and out. A lot of it without access to the original source code. Sometimes even having access to the original source code doesn't help. So imagine a build process for an application that has a C++ runtime and a C# scripting layer. So there's two different languages that two different systems running one on top of each other that need to talk to each other. So when you have an architecture of this type, and you need we need them to talk to each other, which is usually what you do, it's customary to just write a tool that generates all the glue code for you. So you can have a bunch of code that just makes both layers talk to each other, and you can automate this because it's fairly, like, it's just annoying code to write, and you want just to have a list of all of the method calls that you need to do and all the data structures that you need to pass around, and you just have those in text files, and then you have a tool that just parses that and generates the appropriate C# and C++ code that makes things work. And I've written multiple tools that do this, so it's a thing. It's a fairly common thing. So the goal of this project was to replace the old tool that was running on the build system with a new tool, preferably with no changes anywhere else. And like, I was tasked with doing this and replacing it with something that was better maintainable and flexible, because the tool that we're talking about here that generates all of this code was a bunch of Perl scripts that took that took in text and output the C# and C++. So the text file would basically be like type and method signatures written in C#. Just like a markup file. So it's like a text file with code and then some markup going, like special markup, like start class and end class and start method and method with markers, just so the parser can know, okay, this is a class. Now I'm just going to generate the class in C# and C++, and we're good. Like, the Perl script would go through all of this thing and generate the correct C#. It was really hard to maintain because people didn't have a lot of knowledge, and it just grew organically. Another one of those tools is just happened to exist, and people would keep adding it to it as a side effect of the things that they needed to do. They needed to just, I need this extra thing to be generated because this API is particularly weird. Let me just add a corner case to this script. So the script was just growing organically with edge cases and exceptions and kind of weird stuff going on over there. It's like, it worked perfectly well, but people would have looked like, oh, no, in this case, you just don't put that markup there, because if you do, it duplicates it. So like, all sorts of hacks and workarounds that were like documented in word of mouth, because people had better things to do than maintain the tool that generated all the code, because that's boring. So the first thing I did was to write a test runner that would take a text file, one of those markup files, and just running through the old tool and the new tool that didn't exist yet, and compare the result of the two. And then I added a test that took every markup file in the code base and run it through the test runner. I immediately had 180 failing tests. Then I wrote tests for every markup tag that the tool supported. These were individual like snippets of text. So it's like just an individual, like how, like a class, how it would be defined, a method, and all these things. And then I got to like maybe 80, 100 tests. So it was like almost 300 tests in total already. So without a single line of code written, I have 300 failed tests, which make me pretty happy because now I can make all of these things green. This gave me a vision of how things were actually being parsed and interpreted by the interpreter, as opposed to by the parser, as opposed to how people thought it was working. Because how people think things work and how they actually work is not the same thing. So I started working my way through implementing all of these things and slowly getting making tests green. After taking care of all of the low-hanging fruit, I only had a few remaining red tests, and that's where things got complicated. You see, no matter how small the system, interactions between components create emergent behavior that you just can't foresee. For these Perl scripts, there's so much emergent behavior, it's ridiculous. It's like one white space in one place would cause something to output incorrectly, and people found out that if you just duplicated a markup tag somewhere else, it would just fix the output. So now there's all sorts of weird stuff going on in the markup files, working around bugs or completely undocumented behavior of the tool. It's easier to just patch and move on than to fix a tool, especially if you're not familiar with the tool source. Some things weren't even bugs. They were just undocumented behavior, right? That people randomly stumble upon, and there's like, oh yeah, that's useful. I'm just going to use that. Like, that is not what the tool is supposed to do, but if it works, I'll use it. So when you're trying to re-implement a black box, even if I have the source code, which I did, but as far as I was concerned, it's still black box. By testing, you do this by testing every input and output and replicating it. It's like, what do you do about the bugs? Do you re-implement all of them as well? It's like, what about all this emergent undocumented behavior that the tool wasn't supposed to be doing, but people were relying on it? It's like a lot of the bugs were completely side effects of the very specific way that Perl script is implemented. So if you're re-implementing this thing in a completely different environment, in a different way, you're not going to do it in the same way. It's not the same implementation. It's not a copy, which means you're going to have completely different bugs and completely different emergent behaviors. So what do you do? So everything else using this tool is assuming these bugs and behaviors exist. So everybody's relying on this because bugs are still things that people rely on. I don't know. Well, I don't know why, but software. So they're either taking advantage of these bugs and behaviors, or they're working around them. So if you don't implement the bugs and the behaviors, you'll break everybody that's relying on them. You either break everybody, or you have to go and fix everything according to what you assume would be the correct behavior. And we're talking about 180 markup files, huge markup files that generate, each one of them generates 180 C# files and 180 C++ tests files. So it's not like, and you're doing this while everybody's still working on the code base, so they're adding like more code every day. It's a fun race. So this is the 99% bug compatibility problem. As in, when I'm re-implementing something, I'm aiming for 99% bug compatibility. I will re-implement 99% of bugs, regardless of whether, because I can't tell whether they're bugs or they were intentional. Like there's nothing saying, or like, yep, this behavior is a bug. It's like nobody's saying this behavior is a bug. It's just the thing that the tool does. Is it a bug? Is it a feature? So I am for 99% bug compatibility. And there's 1% of bugs and behaviors that are so completely disruptive to the system that they just compromise the whole design and are not worth it, basically. So the last 3 tests that I needed to fix were in that 1%, because it's always like that. It's like always the last thing is just like, if you do it, if you make it green, you're just going to break everything, because it's just going to bring everything down. To fix them, I would have had to replicate parsing bugs in the original tool. And it was completely like, no, I'm totally not doing this. And at that point, running the tests through the old and new tool to compare them was no longer valuable. And so I stopped using the old tool as a source of information of what the new tool should output. And I switched to comparing master files that I created with the outputs that I expected the tool to have, fixing the bugs that I will not fix on this parsing tool. So, and then I went around and fixed the markup files to undo all the hacks that people had added to go around these weird behaviors of the tool. So in the end, when the branch that replaced the old tool with the new tool went into production, nobody noticed, which was the point. It was like, hey, I'm just going to quietly come here and replace this, and nobody notices. So this type of testing is a special kind of testing. It's taking a system that already exists and trying to figure out how it actually works by throwing in many tests as possible at it and trying to figure out all of the corner cases, like trying to trigger all of the weird interactions between components that happen when you throw in data at it. It's almost like fuzzing in security, where you have a tool that just throws input at something, trying to figure out if there's some unprotected area of the code base that breaks on certain types of input, almost like fuzzing. I really enjoy these kinds of tests, because it's just fun trying to figure out how things should work, or how they actually work as opposed to how they should work. So, and then there's functional tests, which are like test plans run by QA of the whole app from the point of view of the user. They're not code tests. They're functional tests. They're testing the functionality from the outside. They can be automated, or they might be manual. They can be exploration tests trying to cover problems, or regression tests making sure existing functionality hasn't regressed. It's incredibly important to ensure that there are test plans and a systematic approach to testing things, because it's completely impossible to have 100% test coverage of the system in code. There's always something that's untestable through code. So these are the last line of defense, basically. So in functional tests and assumptions, there's the case of the missing ends. When I was working on Mono, and I was implementing Windows Forms, which is the old C# API for building Windows applications, which is just one step above the very old native Windows Win32 API. So I was implementing how controls got focus. So I'm just going to show you. This is actually a screenshot of a Windows system today, so nothing has really changed from 10 years ago or whatever when I was doing this. Yes, 10 years ago. I was implementing, we had no source code access. So Mono is a .NET implementation that runs on Linux. We had no source code access to .NET, and we could not look at the compiled code because we were implementing this in a clean room environment to guarantee that we are not copying implementation. So we just have to throw data in, figure out how it works, and then re-implement it. So in this case, I needed to figure out the correct sequence of events that gets raised whenever you click on a control in a dialogue like this one, right? What events, what are the order of events, like the focus events that the code, the application is written on is receiving, when they go, like, when does it receive? Does the window receive the focus event, and then the container, and then the text box or whatever receives, and how it is visually shown. So in this case, Windows loves to do these little ant lines around selections in the UI. And these, we call them ant lines because they look like little ants. If we got the sequence wrong, because we were emulating all of this behavior to run existing applications, if the sequence is wrong, existing applications would just break because they're expecting a certain order of events in order to be able to react. Like if like validating text boxes when you exit a text box and you lose focus on it, and stuff like that. So I spent days creating test apps to try and figure out the logic behind how Windows sends focus events and what visual indicators show up. And then I finally had like a map of the whole thing and implemented it. And I was very happy with it. It worked. Amazing stuff. I push the branch and go, yay, finally fixed it. Please, someone do a sanity test for me. We didn't have QA. It was like just everybody else on the team firing up their machines and poking at things. We also had a lot of users sending us applications that they wanted to run and go like, please make this work, which is really nice because you have something that's practical and you can make it work. So someone tried this and their results were completely different from mine on Windows. This wasn't something running on Mono on Linux. This is the actual test app had a completely different behavior on his Windows machine than it had on mine, which is a problem because did I mention that assumptions are the mother of all things? Yeah. So I was working under the assumption that I was re-implementing a known behavior, a thing, a US SDK written in C# and that the behavior was universal. And it was like, no. Turns out all of the UI controls on WinForms are just a layer on top of the actual controls, a lot of them. So this one is an actual system native control. This, if you say print on the C# app, it will not show a C# control. It will show this thing, which is a native control rendered natively by Windows. So, and Windows has a bunch of options that control the visual, how the OS is going to be rendered, like how it shows up. And some of those options change the way Windows shows focus highlights, like the little ant lines. Some of those options have absolutely nothing to do with focus indicators at all. They just change something in the system that ends up affecting how focus indicators show up. All my tests had been on Windows XP with one theme, and this person was testing on Windows XP with a different theme. This is literally 10 years later. I took these two screenshots in a 2-second interval today on my machine, and I did absolutely nothing. And one of the screenshots has the ant lines, and one of the screenshots doesn't, and nothing has absolutely changed as far as I'm concerned. So, moral of the story. I mean, we decided to just take one of the versions. Let's decide that on this, they put the ant lines there and we'll just run it. And if people complain, goes like, yeah, it works on my machine. Or well, the Windows is weird, whatever. But the moral of the story is when QA is running test plans, there might be a lot of things that the developer assumes QA knows about how the feature works that they actually don't. The developer might not be aware of their own assumptions of the limitations of the system they're working on. They think that the behavior that they're doing is universal when it isn't. And then they pass it on to someone else and then they test and they go like, nope, this doesn't work. And you go like, what? So ideally, QA is involved in test plans and testing features as early as possible to make sure that any bad assumptions or limitations of the way things should be working are checked by an external source. It's test early, test often, with limitations because things aren't done, but still external input and vision is important. Let's just say that. And so like having QA on board as early as possible in any feature development ensures that they are aware of all the conversations around what you're doing and that they know how things are expect it to work, and that they can test in systems that you are not expecting them to work. And for QA people, be aware that developers sometimes are not aware of all of the limitations inherent to the things that they're using. So assumptions need to be checked in all things. So it's, do we have 45 minutes or an hour? I have another story that I can tell or not tell, depending on whether we are going to run over time.
You can move forward. Like, we have plenty of time.
Okay, cool. Okay, so speaking of assumptions, my final story is the $6,500 bug, and this one's my bug. So it's a fairly recent bug. This was around June 2015, I think. I pushed a fix to a checkbox. So this is the checkbox. You can see it here, right here, like this checkbox. So I pushed the style fix just to tweak the style of the checkbox. So this checkbox is a part of the form that you see here that publishes repositories. When you're in Visual Studio, you can publish your repository, local Git repository, to GitHub. And this form is living in an area of Visual Studio, which is called Team Explorer. So like this area right here is not ours. I didn't do this. This is Microsoft's. It's like these are sections of the Team Explorer pane. Is a little pane, and all these sections, people can just put things in there, and we put the little publish to GitHub going on. So like for some reason, the Team Explorer pane doesn't follow the default styles that Visual Studio has for the checkboxes and buttons and everything. And like Visual Studio has all of these very nice adaptable styles so that you don't have to worry about how things are rendered and whether you have accessibility, because Visual Studio has all of this stuff built in that you can use. For some reason, the Team Explorer team has their own custom styles for some of their UI controls that don't follow or don't inherit, I guess, the defaults in Visual Studio. And the checkbox in particular show up slightly different. So they're completely flat in this style when the rest of Visual Studio never shows flat checkboxes. They have a different style for that. So in earlier testing, we had an issue filed about the fact that we were in this area, but the checkbox didn't look the same as the rest of the checkboxes in that area. And because we're the only third party in this area, it's kind of a big deal to make sure that like things look nice, right? It's important. UX is important. UI is important. So I went in and tweaked the style as much as possible, because I couldn't use their styles, and I really didn't want to re-implement, because that would have been disruptive and potentially buggy to re-implement the checkbox style in a way that matched theirs, because then I would have to test against all of the behaviors, like the accessibility and high contrast themes, to make sure that it worked on all of them. It's a massive thing. And I just went in and did a small tweak to kind of like match it as much as possible. So this checkbox controls whether the repository is going to be published like publicly or privately, which is important, kind of important. And then that happened on August 31st. So, which is, let's just say, not good. This is the nightmare scenario of all ships, basically. So this person was using GitHub for Visual Studio, and they had a local repository, and they had AWS tokens, Amazon AWS tokens, checked in the local Git repository. And when they went to publish the repository, they checked the little box that said private, and they pushed, and they went to bed. The next morning, they wake up to find a bill from Amazon of $6,500 for AWS usage. The repository had been published publicly instead of privately. And there are bots, in case you don't know this, there are bots that automatically just scan for AWS tokens and passwords and all sorts of information and just grab them if they're public. If your code is public, anyone can do this, and like people have bots that do this stuff. No matter how much we try to prevent this stuff from happening, like it happens. So a bot had grabbed their AWS token and had used it, put it to good use, as they say, during the night while he was sleeping. So now, when this came out, I was asleep, because all of this happened when the U.S. West Coast was awake, which means it was like 1 a.m. Copenhagen time or something like that. And by the time I woke up in the around like 5, I woke up around 5:30 in the morning. For some reason, I didn't sleep well that night. I don't know why. Maybe it was premonition. But by the time I had woken up, the team had fixed it, shipped the patch, published a new version in the marketplace, and the API that publishes repos on GitHub had been blocked, so that it blocks by the version of the GitHub extension, so effective versions would not be able to publish repos. So if you had if you try to publish with a bad GitHub for Visual Studio version, you would not be able to publish. And this is like hooray for remote distributed teams, so that we can actually do this on a 24-hour basis if something goes wrong. So what happened? Apparently, a very harmless change of styling to the checkbox had caused the click event on the checkbox to not be propagated to the click handler and the code that actually set the flag. Visually, everything was fine. The checkbox looked checked, but the code never got the event, so it never actually fit the flag. All our unit tests passed, of course, because they were testing the code in the backend after it got the event. All of the components individually were working great. Integration tests didn't catch this, because they would only test that once the event was raised, that all of the systems worked as intended. It wouldn't test when you click the checkbox, but the event actually didn't get raised. The only way to pick up a problem like this would be with automating Visual Studio itself and a functional test to validate externally that if you clicked on the box, eventually the thing that got published was matched what you clicked on the box, because that would be like the only way of ensuring that the flow was actually correct. We didn't have, and we still have very limited automation for Visual Studio for testing GitHub for Visual Studio, because it's automating all of Visual Studio. And our manual test plan that we had didn't actually go all the way. Like the test said, check this box and make sure it's like it works. But make sure it works is just making sure that the checkbox looked checked. It didn't actually go, the manual test plan was not explicit in check this box and publish it, and then validate that what you published matches what the box got checked. The test plus was not explicit enough in this. So it missed manual testing as well. We've since improved our testing practices to make sure nothing like this ever happens again. It's because it should never happen. Still, I mean, automation testing is hard on native applications in general. And like the bigger the application, the more things can fail and the more time things take to test. Like in Unity, a full test run takes days in automation. So like it's incredibly hard sometimes to ensure, like, to pick up on these things, and the cost benefit of implementing a whole automation system is just hard to measure sometimes. But on the other hand, bugs like this, right? So sometimes it's the simplest of changes. It was just a style change. I was just trying to make the checkbox look nice. So yeah. Moral of the story: test everything, all of the things, basically. And everything that you have that is sensitive information, be paranoid. Be very, very paranoid about it. So that was my last story. Thank you for listening.